couple of different vocabulary words. And they're all really important, but the most important ones are this concept of domain and range that we're going to talk about. It's going to be something like what we talked about yesterday, what's a function, what's not a function. What we talk about today, domain and range. These are going to be concepts that will be important in every single math class that you take. Okay? So just throwing that out there. This chapter is very, very important. So how many coordinates, how many ordered pairs do we have here? All right, we have 6. How many do we have over here? How many do we have?
Infinite.
We have an infinite number of ordered pairs. When we have a continuous graph, I can be really obnoxious and be like, here's a coordinate, here's a coordinate, here's a coordinate, here's a coordinate, here. I mean, we can just fill these up with as many dots as we can. Okay, we have an infinite number of points that are connecting to be that curve. Okay, so this picture right here, this is what we call a discrete relation, okay? Because there is a finite number. We can count them. A finite number of ordered pairs. However, if we have a continuous relation, basically we could like draw it with our pencil, like not make dots, but like draw the curve, okay? Those contain an infinite number of ordered pairs. Okay. All right. So we have these vocabulary words, domain and range. Okay. Okay, so I'm going to tell you, I want you to write it right here. Domain, not Damien, domain are all of your inputs, and range are all of your outputs, okay? It's basically categorizing them, okay? So most of the time, our inputs are the X's, right? And our outputs are the Y's. Sometimes we're going to see different variables. That's fine, okay? But I want you to understand that domain is asking you, hey, what are the inputs? Range is asking you, hey, what are the outputs? Okay? So when we look at number 1 right here. Sorry, did we get that all? Okay. When we look at number 1 and I ask you, hey, what's the domain? Okay. When we have a discrete relation, it is really easy to pick out the domain and range because you're literally picking out those X coordinates for the domain, the Y coordinates for the range. Okay. So like, what are our X coordinates here for number 1? Okay, -2, -1, 10, and 9. But if we look at our Y coordinates, how many unique Y coordinates do we have? 3. I'm going to list 1, 5, 6. Why did I do that?
Because there's 2 1s.
Okay, A, 2 different coordinates have a 1. B, I put them in numerical order. Is that okay?
Do we have to put them in a numerical order?
It helps me. If I'm like grading your paper, if they're in numerical order, it helps me save time. And that's probably a good habit for you to have, to write numbers in order when you make a list. Okay? If you don't, I'm not going to count off for it, but I would like you to. Okay? Is this a function?
Yes.
You betcha. It is a function. Okay. All right. Number 2, our domain. What are our inputs?
3, 4, 5.
3, 4, and 5. Okay. We're looking at all of our x coordinates, right? Our domain, our range, we're looking at all of our y coordinates. Okay. If I were to write the range, I would write this. -3, -1, 0, 2, 4. Because I would rearrange them so that they are in order. Okay. What's the, oh, is this a function?
No.
Sad day. Who's the problem?
The 3s and the 4s.
The 3s, ooh, there's 2 problems. The 3s have 2 different y's and the 4s have 2 different y's. That is a bummer. Okay. All right, how about you and your elbow partner or you and your table? We have some absences today. Write down the domain and range for 3 and 4. All right. The domain for number 3. Eva, what do you have? 1, 2, and 3. It's kind of nice they already have it in order for you, right? Okay, Vivi, what about our range for number 3?
3, 7, and 8.
Love it. Okay. It's a terrible brace. I got it. And everybody, is this a function?
Yes.
Yes, you betcha it is. Okay. All right, number 4, Jace, what's our domain?
4 and 8.
Okay. Okay, Emily, what about our range?
1, 6, and 10.
Everybody, is this a function?
No.
No, sad day. 4 is being mapped to 2 different numbers. Okay? All right. Now, when we are asked for the range or the domain from a discrete relation that is a graph, we need to basically go from left to right to get our x values. We need to go from top to bottom to give us our y values. So for our domain, from left to right, my first x value happens at -4. Then I have another coordinate at x is -1. Then we have another coordinate or 2 at x is 2. And then another coordinate at x is 4. Okay? It's okay if your domain has less numbers than the number of coordinates because remember, we could be doubling up. Okay? Now our range, we're going to go from top to bottom and kind of just, scan where we have points. So we have a y coordinate right there at -3, right? Okay. And then we have a coordinate right here at 0. And then we have a coordinate here at 1. And then we have a coordinate here at 2. And then here again at 3. Okay, function?
No.
No. What is our reason?
Coordinate two.
Two has two outputs.
Okay, so anytime there's a graph, I am totally okay with you referencing the vertical line test. It does not pass the vertical line test. At x equals 2, we have two outputs, so it doesn't pass the vertical line test. Okay? Okay, you work on 6 and 7 real quick. All right, for number 6 is your domain. -2, 0, 1, 3, 5. Does that sound right? Is your range -2, 1, 4? Does that sound right? Okay, there's more x's than y's. Is it a function? It is a function. Watch, guys, if I draw a vertical line and I 1 dot, 1 dot, 1 dot, 1 dot, 1 dot, we're good. Okay, now how about 7? If I put my vertical line, do we have a problem?
Yes.
Right here, we do not pass the vertical line test. Okay. All right. Your domain, do you have it listed as -4, whoops, -4, 0, 2, 3?
Yes.
And your range as -3, 0, 1, 3, 4? No, not a function. Okay. Now, when we have a continuous relation, we can't just say 1, 2, 3, 5, 7. We have an infinite number of points. We can't do that. Okay? So we're going to take a little bit of a timeout from the blue sheet. And I am going to have you on Google Classroom, under today's post, there is a link I want you to click. Okay? And it's going to ask you to sign into thought you could continue without signing in. Okay, now this is something that I'm totally okay with you working on. Like, talk to each other while you're doing it. Okay, but what I want you to do, it's kind of gonna help you get an idea for what domain and range looks like visually with a continuous function. So watch how when I put it here, it's gonna say awesome. Why does it say awesome? I lined it up with the start and the end. And then it's gonna ask you to choose which one of these makes sense for this blue window. Okay? So it's gonna do a few of those for domain and then a few of those for range. So I want you to work through those and see what you think. Okay? I do want you to talk to each other a little bit while you do this. Which one of these would you click? -3 to 6, like this guy right here. Okay, good. Okay, so then when you click next, you go to the next one. Okay. So that one has an arrow that keeps on going. So we click, it just keeps on going. It's not a sandwich. Hmm? So that one would be this one. It's just greater than or equal to -1 because it's just gonna keep going. The one that has an arrow, there's no sandwich. It's just gonna keep going. Yeah, but you're right with the So it's gonna keep going because there's an arrow. So we're gonna choose this one. It's not gonna stop. Okay, no matter where you are, click next. Can you go to slide 7? I want you to do at least slide 7 and 8 before I make you stop. Okay. Slide 7 helps you start thinking about range. matter how far you got, like I really wasn't needing you to get through the whole entire thing, but I just needed you to have this visuals of like that blue and that green. Okay, so what I'm going to ask that you do is just quietly close your computers. Don't put them away. Just quietly close them, and we're going to go back to our blue sheets. Okay. Okay. When we are trying to determine the domain and range of a continuous function, I want you to have that visual of like going from left to right, where's the blue? Going from bottom to top, where's the green? Where are we going to have coordinates across the graph? Okay? So if we look at this first one right here, if we go from left to right, where are we going to start having coordinates? At 1, and then they're going to continue to the right of 1. Do you agree? Yeah. So we would describe our domain as x is greater than or equal to 1. That starts at 1 and gets bigger. Okay? Now, understanding that this arrow means it's going to keep on going. When we go from bottom to top, do we have like a starting point or an ending point? Like those are going to continue to go down and up. Do you agree? So we are going to say all real numbers, and I'm going to show you a cool symbol. Instead of having to write all real numbers, this really cool R with 2 backs means all real numbers. That's what that means. Sound good? Okay. Is this a function?
No. So technically, the negative would be below the graph, because it's starting with 4 squares.
Yeah, so this is all down here is negative, all up here is positive.
Okay.
Yep, that's exactly right, Joey. So look at number 1. This is a parabola. This is something that eventually next semester we're going to be able to graph. So when we go from left to right, do I have a very left starting point? No, because it's going to keep going, right? Okay, do I have a very right ending point? No. So what are we going to call our domain? All real numbers. Okay, but our range is not like that. Our range does have a starting point, doesn't it? Okay, right here we're starting at y is okay, and are we bigger than -3 or smaller? So y is greater than or equal to -3. Okay. Now number 2 is kind of weird, don't you think? I like it though. I think graphs like this make domain and range easier because when we go from left to right, we have a starting point, don't we? Yes. Yeah, if we think about that blue, right? We start right here at x is -2. Okay, and we get bigger, don't we? So x is greater than or equal to -2. Okay. Now, when we think about like the green, that's more of like an ending point, don't you agree? Okay. We end at y is 3 and everything else is smaller than it. So we would describe the range as y is less than or equal to 3. Because it stops at 3, but it continues on down. Is it a function? Yeah. Kind of boring. Okay. Ooh, look at number 4. It has an open circle. You're not laughing at me, right? Okay, that's good. Okay, so when we think of our x's from left to right, we are starting at -2. Do you agree? And we keep going to the right of it. But what's going to be different about this inequality?
It's gonna have a, it's not equal to, so it's just gonna be
X is greater than -2. Since it's an open circle, we're not going to worry about the equal to. Okay, now let's look at the range. So I'm going to use my green. It looks like I start here and I go up. Okay, is there an open circle at y is -3? No, it's a closed circle. So we can say y is greater than or equal to -3 because that open circle is not affecting our range.
I would say maybe extraction for the one that's greater than or less than is maybe would be parallel lines.
Oh, yes. Yes, if it's going up versus down. Yeah, I like that. Okay, here's the deal. We have a long weekend. I know that. In the 11 minutes that we have left in class, I could keep doing examples, or you could open your computer and you can do problems 13 through 22. What do you think? Yeah. You want to do that? Okay. I'll just make sure we